Have you ever tried to truly understand what a light year actually means? Not just the textbook definition, not just the phrase itself, but the real distance hidden inside those words. Because a light year is not a measure of time, even though it sounds like one. It is a measure of distance. Specifically, it is the distance that light travels through empty space in one full year. That explanation sounds simple enough at first. But the moment you pause and try to feel what it means, something unusual happens. The numbers begin to detach from ordinary experience. Your mind hears them, but it does not easily hold them. A kilometer feels understandable. 100 kilometers still feels real. Even 1,000 can be imagined with effort. But a light year exists far beyond the scale of roads, cities, oceans, or even planets. It belongs to a different category entirely. Light moves at approximately 299,792 kilometers every second. That means in the time it takes to blink, light could circle Earth more than 7 times. In 1 second, it crosses the space between continents. In 8 minutes, it travels from the Sun to Earth. In a little over 1 second, it reaches the Moon and returns. Already, even these smaller examples begin to stretch intuition. But a light year asks us to continue far beyond seconds and minutes. It asks us to imagine light moving at that incredible speed without slowing down, without resting, without interruption, every second of every day, for an entire year. And that is where the numbers become so large that they stop behaving like numbers in the human mind. A light year is about 9.46 trillion kilometers. Written down, it is only a statistic. But truly feeling it is something else. It is the distance between what we can calculate and what we can emotionally comprehend. Before we continue, we just want to say that we genuinely appreciate you spending your time here with us. It's always fascinating to see where people are watching from, so feel free to leave a comment and tell us where in the world you're listening from tonight. And if you enjoy calm, long-form journeys through astronomy and the universe, consider subscribing to the channel. It truly helps us continue creating these slow explorations of space. Now, as we return to the idea of a light year, it helps to understand why astronomers use it so casually. They do not use it because they are trying to sound dramatic. They use it because the universe is so large that our everyday units become awkward almost immediately. Saying a nearby star is 40 trillion kilometers away is technically correct, but it hides meaning beneath too many digits. Saying it is 4 light years away tells us something more elegant. It tells us that the light entering your eyes tonight left that star 4 years ago. It transforms distance into travel time and travel time into perspective. This is one of the quiet genius ideas in astronomy. Instead of measuring cosmic emptiness in kilometers, we measure it in the journey of light itself. The fastest thing we know becomes our ruler, and even then, the distances remain immense. Because once you begin speaking in light years, you quickly discover that stars are separated by many of them, galaxies by millions of them, and the observable universe by billions. A light year is not just a unit. It is the first step into realizing that space is larger than the human brain was ever designed to naturally imagine. And as we continue, we will slow everything down and build that scale piece by piece until the impossible begins to feel, if only briefly, almost real. To understand a light year, we first need to understand the thing it is built from, light itself. Because a light year is not based on cars, rockets, aircraft, or anything humans have invented. It is based on the fastest speed known in the universe. Light moves through empty space at approximately 299,792 kilometers per second. That number is so extreme that it can feel abstract immediately, so it helps to slow it down into moments the mind can grasp. In a single second, light can travel around the entire Earth more than 7 times. It can move from London to New York and back several times before 1 second has fully passed. It can cross continents, oceans, and skies faster than the brain can register the passage of time. This leads to the first important realization. Many of the distances that feel large to us are tiny compared to the speed of light. Think about everyday movement. A person walking covers a few kilometers in an hour. A car may cross a country in several hours. A commercial airplane can move hundreds of kilometers in 1 hour. A spacecraft launched from Earth can travel faster still. These speeds once seemed extraordinary, and in human terms, they still are. They shrink geography, connect cities, and allow us to move across the world in ways earlier generations could barely imagine. But compared with light, they are almost motionless. Even the fastest human-made spacecraft move at only a tiny fraction of light speed. If a passenger jet were racing beside a beam of light, it would appear almost frozen by comparison. This is why cosmic distance requires a different ruler. Human speed is too slow for the scale of space. Now imagine 1 minute of non-stop travel at light speed. In 60 seconds, light covers nearly 18 million kilometers. That is enough to circle Earth hundreds of times. In 1 hour, light travels more than 1 billion kilometers. In a single day, it crosses over 25 billion kilometers. By now, something subtle begins to happen in the mind. The numbers are still understandable mathematically, but emotionally they start to blur together. Millions, billions, tens of billions. This is normal. The brain evolved to judge distances that could be walked, seen, or crossed within a lifetime. It was never required to deeply feel what 1 billion kilometers means. And yet, astronomy asks us to do exactly that. This is one reason space can feel both humbling and calming. It reveals the limits of our intuition without threatening us. It quietly shows us that the universe operates on scales beyond instinct. When astronomers talk about nearby planets, stars, or galaxies, they are often speaking in distances where light itself needs time to travel. Even at the fastest speed possible, space remains vast. That alone changes how we think about nearness and farness. Another remarkable detail is that nothing with mass can simply accelerate beyond light speed, according to our current understanding of physics. Light is not merely fast. It is the upper limit built into the structure of space and time. This means a light year is based on the greatest speed nature allows. It is the longest ruler we can reasonably begin with, and even that ruler soon feels too small once we step beyond our neighborhood of stars. So before we even reach the full concept of a light year, we already learn something profound. The universe is so immense that even the fastest thing known needs years to cross parts of it. And as we continue, we will begin to stretch this speed across longer and longer spans of time, 1 second becoming 1 minute, 1 minute becoming 1 hour, until that final leap into a full year reveals just how extraordinary a single light year truly is. Now that we have slowed light down into seconds, minutes, and hours, we can begin the gradual climb toward a full year. This is where the true meaning of a light year starts to emerge. Because the concept itself is simple. Take the fastest speed known in nature, let it travel continuously through empty space, and measure how far it gets after 1 complete year. But while the sentence is simple, the scale it produces is not. The mind can follow the logic easily, yet still struggle to feel the result. And that tension between understanding and intuition is part of what makes astronomy so fascinating. Let us begin again with 1 second. In a single second, light travels nearly 300,000 kilometers. In practical terms, that is enough to circle Earth more than 7 times. It is a distance so extreme that it already surpasses most human reference points. Now extend that to 1 minute. Multiply 60 seconds by nearly 300,000 kilometers, and light travels almost 18 million kilometers. In just 1 minute, it has moved farther than any human being has ever physically traveled in a lifetime. Continue to 1 hour, and the number becomes more than 1 billion kilometers. Already the scale has entered territory where numbers stop feeling personal. They become measurements rather than experiences. But light does not stop after an hour. It continues through the next hour and the next, crossing darkness with perfect consistency. After one full day, light has traveled more than 25 billion kilometers. This is where perspective begins to shift. Earth, which once felt vast, now seems small. The circumference of our planet, the width of oceans, the distance between nations all begin to shrink into local details. Even the distance from Earth to the Sun, about 150 million kilometers, can now be crossed by light in roughly 8 minutes. The sunlight that warms your skin today began its journey only minutes earlier. That fact alone quietly links daily life to cosmic scale. Now continue beyond one day. Light travels through a week, then a month, then season after season without slowing down. It does not need fuel stops. It does not rest. It simply moves at the same astonishing speed through the vacuum of space. After one full year of uninterrupted travel, the total distance reaches approximately 9.46 trillion kilometers. Written numerically, it is 9,460 billion kilometers. A row of digits so long that the eye stops caring halfway through. And this is exactly why the term light year exists. It compresses an impossible number into something usable. But something deeper happens when you think about it carefully. A light year is not only distance, it is also a story of persistence. It is the result of one uninterrupted journey at nature's maximum speed, sustained for an entire year. It transforms time into scale. Instead of saying something is trillions of kilometers away, we say its light needs years to reach us. Suddenly, distance becomes something the mind can relate to more naturally. Years are human. We know what a year feels like. Birthdays, seasons, routines, memories. When we hear that a star is 10 light years away, we are hearing that its light began traveling toward us 10 years ago. This is where astronomy becomes strangely intimate. The stars above are not only far away, they are delayed messages. Every point of light carries travel time with it. Some left before your last vacation, some before you were born, some before recorded history. A light year, then, is more than a unit. It is the bridge between speed, time, and distance. And as we continue, we will use that bridge to step outward from our solar system toward the nearest stars, where even our closest neighbors already live multiple light years away. Now that we have followed light from a single second all the way to a full year, we can begin to use that distance in a real context, not as an abstract number but as a way to measure the universe around us, because a light year becomes meaningful the moment we apply it to something we can point to in the sky. And the first place to begin is just beyond our own solar system. Within the solar system, distances are large, but still manageable in terms of minutes or hours of light travel. Light from the Sun reaches Earth in about 8 minutes. From Earth to the outer planets, it may take hours. Even at the edge of the solar system, where objects like the Kuiper Belt exist, we are still talking about distances that light can cross within a single day. This tells us something important. The solar system, while vast on a human scale, is still very small compared to the rest of the universe. It fits comfortably within a fraction of a light year. The moment we step beyond it, everything changes. The nearest star system to us, known as Proxima Centauri, is about 4.24 light years away. That means the light reaching Earth from that star tonight began its journey more than 4 years ago. It left that star, traveled through the emptiness of space without interruption, and only now arrives here. This is the first true moment where the concept of a light year becomes real, not as a calculation, but as a connection. When you look at Proxima Centauri, you are not seeing it as it is right now. You are seeing it as it was over 4 years in the past. This shift in perception is subtle, but profound. It means that distance in space is also distance in time. The farther away something is, the older the light you are receiving. This turns the night sky into something more than a collection of distant objects. It becomes a layered view into different moments in history. Nearby stars show us relatively recent light. More distant stars show us older light. And beyond them, galaxies reveal light that has traveled for millions or even billions of years before reaching us. But before we move that far, it is worth pausing at this first step. 4 light years. That is the distance to the nearest star beyond our Sun. It may not sound extreme at first, but consider what it represents. Even at the speed of light, it takes more than 4 years to cross that gap. If we tried to travel there using current spacecraft technology, the journey would take tens of thousands of years. Generations would pass without ever arriving. This comparison reveals something quietly powerful. The distances between stars are not just large, they are fundamentally different from anything we experience on Earth. And yet, despite that separation, we are still connected through light. Photons travel across that immense distance, carrying information from one star system to another. This connection is slow by cosmic standards, but it is constant. It allows us to observe, measure, and understand objects that are far beyond our physical reach. As you reflect on this, the idea of nearby begins to change. In everyday life, near means something you can reach within minutes or hours. In space, near can mean several light years, a distance that requires years of travel even at the fastest possible speed. This is the first real expansion of perspective. And as we continue, we will move beyond the nearest stars and begin to explore the larger structure of our galaxy, where light years stack into tens of thousands, forming patterns and distances that stretch far beyond this first step into interstellar space. Now that we have reached the nearest stars, we can continue outward into the larger structure that surrounds them all, because stars are not scattered randomly through space. They gather into enormous systems called galaxies, vast islands of stars held together by gravity and moving slowly through cosmic time. Our own home galaxy is known as Milky Way galaxy, and understanding its size is one of the clearest ways to feel what light years truly mean. On a dark night far from city lights, the Milky Way appears as a pale band stretched across the sky. For most of human history, it was simply a mystery, a glowing river of light overhead. But today we know that soft band is made of countless distant stars, so many and so densely packed that they blur together into a luminous haze. What looks delicate from Earth is, in reality, colossal beyond easy comprehension. The Milky Way contains hundreds of billions of stars, along with gas, dust, planets, and dark matter, all orbiting a common center in a slow gravitational dance. Its shape is often described as a spiral galaxy, with curved arms winding outward from a brighter central bulge. Our Sun does not sit in the center. It lives in one of the spiral arms, quietly orbiting the galactic core at a distance of roughly 27,000 light-years. Even this single fact changes perspective. The star that gives us daylight is not centrally placed or especially privileged. It is one star among hundreds of billions, located far from the crowded heart of the galaxy, moving through space as part of a much larger system. Now consider the full width of the Milky Way. From one side to the other, our galaxy spans roughly 100,000 light-years. To cross it at the speed of light would require 100,000 years of uninterrupted travel. That means if a beam of light began from one outer edge when early humans were first painting caves on stone walls, it still would not have reached the opposite side today. This is the scale of the structure we already live inside. And yet from Earth, it can look like a faint streak, no wider than a hand held at arm's length. This contrast is one of the recurring wonders of astronomy. Immensity often appears quiet. The largest structures do not announce themselves with noise. They reveal themselves through patience and perspective. It also means that when we look across different regions of our galaxy, we are seeing different ages of light at once. A star 500 light-years away appears as it was 500 years ago. A star near the galactic center may be showing us light that began its journey long before modern civilization existed. Every direction in the sky becomes a view across both space and time. Imagine shrinking the Milky Way down to the size of a continent. Our solar system would become smaller than a grain of dust. Earth itself would vanish into scales too tiny to notice. This is not meant to diminish us, but to clarify proportion. Human life unfolds on one layer of reality, while the galaxy exists on another entirely. Both are real, both matter, but they operate on dramatically different scales. And still, the Milky Way is only one galaxy among many. What feels overwhelmingly large to us is modest in the wider universe. There are galaxies larger than ours, denser than ours, stranger than ours, and separated from us by millions of light-years of darkness. So if the Milky Way already stretches the mind, it is only the beginning. For now, though, it is enough to pause here, to realize that the faint band above your head is not a decoration of the night sky, but the inside view of a galaxy 100,000 light-years wide. We are not looking at something outside us. We are looking from within it. And in the next part of our journey, we will step beyond our galactic home and begin crossing the distances between galaxies themselves, where light-years multiply into millions, and the scale of space grows quieter, colder, and even more profound. Now that we have crossed the breadth of our own galaxy, we can take the next step outward, a step so large that even the Milky Way begins to feel local. Because galaxies themselves are not the final structures of the universe. They are separated by immense gulfs of darkness, each one carrying hundreds of billions of stars, drifting through space like luminous islands in a cosmic ocean. Once we begin measuring the distance between galaxies, the light-year must expand again, not by dozens or thousands, but by millions. The nearest large galaxy to our own is Andromeda Galaxy. On clear nights from dark locations, it can sometimes be seen with the unaided eye as a faint smudge of light. Soft, distant, almost easy to overlook. Yet that subtle blur is an entire galaxy containing perhaps 1 trillion stars, and it lies approximately 2.5 million light-years away. The light entering human eyes from Andromeda tonight began its journey long before modern humans existed in their current form. While that light was crossing space, continents shifted, species rose and vanished, civilizations appeared, and countless generations lived entire lives without knowing where it came from. This is where the meaning of distance changes once again. Within our galaxy, thousands of light-years felt extraordinary. Between galaxies, millions become normal. If you could travel at the speed of light itself, the fastest speed nature allows, reaching Andromeda would still require 2.5 million years. No human story has ever lasted remotely close to that long. Entire branches of human evolution unfolded in less time than a one-way journey at light speed to our nearest major galactic neighbor. And yet Andromeda is close in cosmic terms. It belongs to our local galactic neighborhood, a small gravitational gathering known as the Local Group. This group contains the Milky Way galaxy, Andromeda, smaller companion galaxies, and many dwarf galaxies orbiting within the same broader region of space. Even here, where galaxies are considered neighbors, the emptiness between them is immense beyond ordinary feeling. Imagine standing on a shoreline at night and seeing another island far across a dark sea. Now imagine that each island contains hundreds of billions of suns, each sun perhaps with planets, moons, storms, mountains, and histories of its own. Then stretch the sea between them, until light needs millions of years to cross it. This still understates the scale, but it begins to create the emotional shape of it. There is also something quietly humbling in the fact that Andromeda appears so small in our sky. It reminds us that apparent size and true size are very different things in astronomy. Something vast can seem tiny when placed far enough away. A galaxy wider than 200,000 light-years can shrink to a faint mark overhead simply because distance overwhelms perception. Andromeda is also moving towards us. Over billions of years, gravity is drawing our two galaxies together, and in the far future, they are expected to merge into a new, larger galaxy. This process will unfold slowly, gracefully, over timescales so long that ordinary language struggles to describe them. By the time it happens, Earth itself may no longer be habitable, yet the motion has already begun. Even in stillness, the universe is moving. As we continue outward, another realization emerges. If one nearby galaxy is already 2.5 million light-years away, what about the galaxies beyond it? What about clusters of galaxies, or regions so distant their light began traveling before Earth existed at all? The numbers ahead become even larger, but they do not become meaningless. They become invitations to widen perspective once more. For now, pause with this single image, a faint patch of light in the night sky, barely visible. And yet it is an entire galaxy whose light has traveled for millions of years just to meet your eyes for a moment. In the next part of our journey, we will move beyond nearby neighbors into galaxy clusters and deep cosmic space where millions of light-years become stepping stones towards something even greater. Now that we have stepped beyond our nearest galactic neighbor, we can continue into an even larger level of structure. Because galaxies are not scattered through the universe in perfect isolation. They gather into families, clusters, and vast interconnected regions shaped by gravity over billions of years. Just as stars gather into galaxies, galaxies themselves gather into something greater. And once again, the scale of distance must expand. Our own Milky Way galaxy and the Andromeda galaxy belong to a relatively small collection called the Local Group. It spans roughly 10 million light-years and contains dozens of galaxies, from major spirals to tiny dwarf systems. Even this local region is already so large that light needs millions of years to cross it. The word local, in astronomy, carries a very different meaning than it does in everyday life. Beyond the Local Group lies something far larger, the Virgo cluster, a massive gathering of more than 1,000 galaxies located about 54 million light-years from Earth. When astronomers observe the Virgo cluster, they are not seeing it as it exists now. They are seeing light that began traveling toward us when the first primates had not yet appeared in their modern forms. That light has crossed darkness for tens of millions of years just to become data in a telescope or a faint image on a screen. Try to pause on that for a moment. A single cluster can contain thousands of galaxies. Each galaxy can contain hundreds of billions of stars. Around many of those stars may orbit planets, moons, and worlds we will never know directly. And this entire congregation of matter is only one cluster among countless others spread through the cosmos. As observations improved, astronomers discovered that clusters themselves are not randomly placed. They form chains, walls, and filaments stretching across hundreds of millions of light-years. Between these filaments lie enormous cosmic voids, regions where galaxies are comparatively sparse. If you could step far enough away to view the large-scale universe, it would not resemble evenly scattered dots. It would look more like a web, delicate and immense, glowing with islands of galaxies connected across unimaginable distances. This pattern is sometimes called the cosmic web. Cosmic web. It emerged slowly from tiny differences in matter density after the early universe expanded. Over billions of years, gravity amplified those differences, drawing gas and galaxies into threads, while emptier regions became wider voids. The result is one of the largest known patterns in existence, a structure so vast that individual galaxies become tiny components within it. Imagine reducing every galaxy to the size of a grain of sand. Even then, the spaces between clusters would remain enormous. Entire seas of emptiness would separate these concentrations of matter. Space is not merely filled with objects, it is mostly made of distance itself. There is something calming in this realization. The universe does not crowd itself. It allows extraordinary room between things. Stars are separated by light years, galaxies by millions of light years, clusters by even more. Scale repeats upward, each level revealing larger forms built from smaller ones. And yet, from Earth, all of this can be hidden behind a simple night sky. A few stars visible to the eye, darkness between them, and silence overhead. It takes instruments, mathematics, and patience to uncover the deeper architecture beyond what sight alone can offer. The sky appears simple only because distance smooths complexity into stillness. As we continue outward, another question naturally emerges. If galaxy clusters and cosmic filaments stretch for hundreds of millions of light years, how far does all of this continue? Where does the visible universe end, if it ends at all? In the next part of our journey, we will approach the scale of the observable universe itself, where distances reach billions of light years, and light becomes a messenger from the earliest chapters of cosmic history. Now that we have followed galaxies into clusters and clusters into vast filaments, we can take the next step toward the largest scale we can meaningfully describe, the observable universe. This is not the entire universe, but the portion we can see from Earth, limited by one simple fact. Light takes time to travel. And because the universe has not existed forever, there is a boundary to how far light has had time to reach us. This boundary is often called the cosmic horizon. Observable universe. It represents the maximum distance from which light has been able to arrive since the beginning of cosmic expansion. Anything beyond it may exist, but its light has not yet had enough time to reach us. In this sense, when we look far enough into space, we are not only looking across distance, we are looking back toward the earliest moments of the universe itself. The age of the universe is estimated to be about 13.8 billion years. At first, it might seem logical to assume that the observable universe would have a radius of 13.8 billion light-years, but something subtle changes that number. Space itself has been expanding during the time that light has been traveling. While photons were moving toward us, the fabric of space stretched, increasing the distance between us and their point of origin. Because of this, the observable universe extends much farther than 13.8 billion light-years. Its current radius is estimated to be about 46 billion light-years. That means the full diameter of the observable universe is roughly 93 billion light-years. A number so large that even the idea of crossing it loses meaning. Even if something could travel at the speed of light, the expansion of space itself would prevent it from reaching many distant regions. The universe is not just vast, it is dynamically changing while we observe it. At the very edge of what we can see lies a faint, almost uniform glow known as the cosmic microwave background. This is not light from stars or galaxies, but the afterglow of the early universe itself, released when the cosmos cooled enough for light to travel freely. It has been moving through space for nearly the entire history of the universe, slowly stretching into microwave wavelengths as space expanded. When we detect it, we are observing a snapshot of the universe when it was only about 380,000 years old. Pause on that idea. Every direction you look, no matter where you point a telescope, eventually leads to this ancient light. It surrounds us completely, like a distant wall of time. Beyond it, we cannot see using ordinary light, because earlier than that moment, the universe was opaque to radiation. The cosmic microwave background is not just far away. It is as far back in time as light can currently show us. Between us and that distant boundary lie billions of galaxies, each separated by immense stretches of space. The further we look, the younger the universe appears. A galaxy seen at a distance of 1 billion light-years appears as it was 1 billion years ago. At 10 billion light-years, we are seeing it in a much earlier stage of cosmic history. This transforms the observable universe into something extraordinary. It is not a snapshot of one moment. It is a layered timeline where distance and time merge into a single experience. And yet, even this immense observable universe may be only a small part of the whole. Beyond the cosmic horizon, space could continue indefinitely. There may be regions so distant that their light will never reach us, no matter how long we wait. This does not make them unreal. It simply places them beyond our current ability to observe. For now, it is enough to rest within what we can see. A universe 93 billion light-years across, filled with structure, motion, and history, all revealed through the quiet travel of light. And as we continue, we will begin to reflect on what these distances mean for us, not just scientifically, but on a more personal level, as observers trying to understand a reality so far beyond everyday experience. Now that we have reached the scale of the observable universe, it is natural to ask a quieter question. What do distances like these actually do to the human mind? Because learning that the universe spans billions of light-years is one thing, feeling it is another. Facts can be memorized in seconds, but perspective often arrives much more slowly. The human brain did not evolve to understand trillions of kilometers or galaxies separated by millions of light-years. It evolved to navigate forests, coastlines, weather, faces, seasons, and paths that could be crossed on foot. Our instincts are excellent at judging nearby movement, familiar space, and immediate survival. But when confronted with cosmic scale, those instincts reach their limit. This is why numbers such as 1 billion or 1 trillion often feel strangely similar. They are mathematically distinct, yet emotionally compressed into the same vague category of very large. A light-year reveals this limitation beautifully. On paper, it is simply a unit of distance, but in practice, it exposes the boundary between calculation and intuition. We can write 9.46 trillion kilometers. We can say the nearest star is 4.24 light-years away. We can state that the observable universe spans roughly 93 billion light-years. Yet saying these numbers does not guarantee that the mind truly experiences them. Often it cannot. And that is not a failure, it is a reminder of scale. Some realities are larger than the mental tools that shaped us. The universe does not fit neatly inside human imagination, and perhaps it was never meant to. What matters is that we keep reaching anyway. There is something unexpectedly calming in this struggle. Cosmic distance can make everyday worries feel smaller, not because they are meaningless, but because they are placed in context. A stressful afternoon, an unfinished task, an awkward conversation, a season of uncertainty, these things can feel consuming when viewed up close. But against the background of stars whose light left before recorded history, the emotional texture changes. Problems remain real, yet no longer absolute. This feeling is sometimes described as awe. Awe, the sensation that something is so vast, beautiful, or profound that the mind must expand to meet it. Awe can be triggered by mountains, oceans, music, silence, or the night sky. Space offers a particularly pure form of it because its scale is genuine, not symbolic. The distances are not exaggerated for effect. If anything, words understate them. Awe has an interesting effect on thought. It can reduce the feeling of being the center of everything. It can soften ego, quiet noise, and invite humility. We remain important within our own lives, but we are reminded that reality is larger than our current concerns. Many people find this not frightening, but relieving. At the same time, cosmic scale can deepen appreciation for small things. In a universe of vast, empty distances, the presence of warmth, friendship, breath, memory, laughter, and consciousness becomes more striking, not less. A candle seems brighter in darkness. Likewise, ordinary human moments can feel more precious when set against an immense and silent cosmos. Even the fact that we are able to understand any of this at all is remarkable. Matter formed stars. Stars forged heavier elements. Those elements became planets, oceans, chemistry, life, minds, and eventually questions. The universe produced beings capable of measuring light years and wondering what they mean. That alone is extraordinary. So perhaps the value of a light year is not only scientific, it is psychological and philosophical as well. It stretches thought. It humbles certainty. It reminds us that existence contains scales beyond instinct, and yet we can still learn to touch them through patience and curiosity. As we continue, we will turn from the vastness outside us to something equally astonishing: how a small species on one planet learned to measure distances it can never physically cross, using only light, mathematics, and the quiet determination to understand. Now that we have reflected on what cosmic distance does to the mind, we can turn to another remarkable question. How did a species living on a small planet, orbiting one ordinary star, learn to measure distances so enormous? How did human beings, who cannot even travel beyond a tiny fraction of their own solar system, discover the scale of stars and galaxies far beyond physical reach? The answer begins with one of the most powerful tools ever developed: careful observation. Long before modern telescopes, people studied the sky with the naked eye. They tracked seasons, noticed patterns, and mapped the motions of stars and planets. The sky was not random. It followed rhythms, and wherever nature reveals patterns, measurement can begin. One of the earliest breakthroughs came through geometry, parallax. If you hold out a finger and view it first with one eye, then the other, your finger appears to shift against the background. Nearby objects shift more than distant ones. Astronomers realized the same principle could be used for stars. As Earth moves to opposite sides of its orbit around the Sun, nearby stars appear to shift slightly against much more distant background stars. By measuring that tiny angle, their distance can be calculated. This was an extraordinary moment in human history. Without touching a star, without traveling to it, distance could be known through motion, patience, and mathematics. The first successful stellar parallax measurements in the 19th century confirmed that the stars were unimaginably far away. The night sky was no longer a decorative dome, it became deep space. But parallax works best for relatively nearby stars. Beyond a certain range, the shifts become too small to measure easily. So astronomy developed additional methods. Certain stars change brightness in predictable ways, allowing their true luminosity to be estimated. By comparing how bright they appear from Earth with how bright they truly are, distance can be inferred. These stars became stepping stones into deeper space. Later, exploding stars, known as supernovae, provided another rung in this ladder. Cosmic distance ladder, some types explode with such consistent brightness that they can serve as standard markers visible across immense distances. Using these methods together, astronomers gradually extended measurement from nearby stars to distant galaxies, then to clusters of galaxies, and beyond. What makes this especially beautiful is that no single method solves everything. Instead, each technique overlaps with the next, building confidence step by step. Nearby distances calibrate medium distances. Medium distances help measure larger ones. Knowledge expands outward like circles in water. Telescopes also transformed the process. Instruments such as Hubble Space Telescope and later James Webb Space Telescope allowed astronomers to detect faint galaxies whose light had traveled for billions of years. These observatories did not physically go to those places. They simply gathered ancient photons that finally arrived after long journeys through space. There is something profoundly elegant in this. We measure the unreachable by studying the light that reaches us. We reconstruct distance from angles, brightness, spectra, and timing. The universe sends clues, and the human mind learns how to read them. It is also worth remembering how recent much of this knowledge is. For most of human existence, no one knew whether stars were nearby lights or distant suns. Today, children can learn that some galaxies are millions or billions of light years away. In only a short span of history, our sense of scale has expanded dramatically. And yet, every answer creates new questions. If we can measure such distances, what else might we someday understand? Could future civilizations map regions we cannot yet see clearly? Could new physics reshape our sense of cosmic scale once again? For now, one truth stands quietly above the rest. A small, temporary species on a rocky world learned to measure the universe using shadows, angles, patience, and light. In the next part of our journey, we will explore what it would actually mean to travel a light year ourselves, and why the distances of space remain so challenging even in imagination. To measure a light year is one thing. To travel one is something else entirely. Numbers can create the illusion that distance is manageable simply because it can be written down. But the moment we imagine physically crossing even a single light year, the true challenge of space reveals itself. A light year is not just a scientific unit. It is a barrier between what can be observed and what can currently be reached. If a modern passenger jet attempted the journey, moving at roughly 900 kilometers per hour, reaching 1 light year away would take well over 1 million years. Human civilizations rise and fall in far less time. Even the fastest spacecraft humanity has launched move at only a tiny fraction of light speed. Voyager 1, one of the most distant human-made objects ever sent into space, has been traveling for decades and has only just begun to move beyond the outer influence of our solar system. At its current speed, it would need tens of thousands of years to approach the distance of even the nearest stars. This is not a technological inconvenience. It is a statement about scale. Part of the difficulty comes from energy. Accelerating any object with mass to extreme speeds requires enormous amounts of power. The faster you try to go, the more demanding the problem becomes. Fuel itself has mass, which means carrying fuel often requires even more fuel. This creates a stubborn engineering challenge that has shaped every rocket ever built. We have become very skilled at reaching orbit, landing on moons, and sending probes through the solar system, yet interstellar travel remains in another category altogether. It asks for solutions far beyond simply building a larger rocket. There are ideas, of course. Solar sail concepts would use sunlight or powerful lasers to push lightweight craft across space without carrying large fuel reserves. Nuclear propulsion has also been studied, using reactions far more energetic than chemical rockets. Some proposals imagine tiny robotic probes accelerated to significant fractions of light speed, reaching nearby stars within decades rather than millennia. These concepts remain difficult, expensive, and largely experimental, but they reveal something important. Humanity has not stopped thinking about the problem. Even if speed were solved, distance creates other obstacles. A crewed mission lasting generations would require life support systems stable far beyond anything yet achieved. Radiation from deep space could damage biology and electronics. Isolation alone would test the human mind in ways we barely understand. Communication delays would grow severe. At 1 light year away, a message sent home would not arrive for a year. Conversation itself would disappear, replaced by long intervals of waiting. And yet, imagining these limits can be strangely inspiring. It reminds us that the stars are not casual destinations. They are separated from us by real physical difficulty, not by a lack of desire. The night sky feels close, because light bridges the gap so effortlessly, but matter does not move so easily. We can see distant stars each evening while remaining profoundly far from them. Perhaps that is why the concept of a light year carries emotional weight. It preserves wonder. It tells us that some frontiers are still genuinely vast, still resistant to convenience, still able to humble ambition. In an age where maps feel complete and travel feels ordinary, the stars remain distant enough to challenge imagination itself. For now, our journeys outward are made mostly through telescopes, mathematics, and robotic messengers. But even that is remarkable. We may not yet cross light years, yet we have learned to understand them. And in the next part of our journey we will explore a deeper truth hidden within distance itself. When we look far enough away, we are no longer only looking outward, we are looking backward in time. The farther we look into space, the further back in time we see. This is one of the most beautiful and unintuitive truths in astronomy. Light doesn't arrive instantly. It travels at a finite speed, crossing distance moment by moment, year by year. Because of that delay, every observation is also a memory. We never see anything exactly as it is now. We see it as it was when its light began the journey toward us. This effect exists even in ordinary life, though usually too subtly to notice. When you look across a room, the light reaching your eyes is only a tiny fraction of a second old. When you look at the moon, you see it as it was about 1.3 seconds ago. The sun appears as it was roughly 8 minutes earlier. If the sun were to vanish suddenly, Earth would continue receiving sunlight for those final minutes before darkness arrived. Distance and delay are always linked. Space simply stretches that relationship into scales dramatic enough for the mind to feel. Consider the nearest star beyond our Sun, Proxima Centauri. Its light takes more than 4 years to reach us. We do not see Proxima as it exists tonight. We see a version of it from years ago. More distant stars may appear as they were centuries earlier. Some visible to telescopes are shown to us from before modern nations existed. Every increase in distance becomes an increase in historical depth. Galaxies make this effect even more profound. The Andromeda Galaxy appears to us as it was around 2.5 million years ago. That means the light we see today began traveling long before human civilization, before written language, before agriculture. When that light left Andromeda, early human ancestors were still walking ancient landscapes on Earth. The image in our telescopes is current only in the sense that it arrives now. Its origin belongs to a distant past. Push further still, and astronomy becomes a direct study of cosmic history. Some galaxies observed by the James Webb Space Telescope are seen as they existed when the universe was very young. Their light has traveled for more than 13 billion years before reaching us. We do not merely theorize about the early cosmos. In a real sense, we observe it. Distance turns telescopes into time machines, not machines that transport us backward, but instruments that allow ancient light to meet the present. This means the night sky is not a single moment frozen overhead. It is a layered archive. Nearby objects show relatively recent events. More distant ones reveal deeper chapters. In one direction, you may observe a star only decades in the past. In another, a galaxy from billions of years ago. The universe presents itself not as one synchronized scene, but as many eras visible at once. There is something deeply moving in this arrangement. The cosmos does not hide its history completely. It leaves traces in motion, radiation, chemistry, and traveling light. By learning how to read those traces, a young species on one planet can reconstruct events that happened long before its existence. We are late arrivals, yet still able to witness ancient chapters. It also changes the meaning of now. On Earth now feels immediate and shared. In the wider universe, simultaneity becomes less intuitive. What is happening right now in a distant galaxy cannot be seen right now by us. Its present is separated from our awareness by the time light needs to cross the gap. The larger the distance, the deeper the delay. So when you look upward, you are not only looking across emptiness, you are looking into a vast museum of traveling moments. Some began recently, some began before humanity, some began before Earth had oceans as we know them. In the next part of our journey, we will explore what happens when distance grows so extreme that even light itself may never fully bridge the gap, revealing horizons beyond which parts of the universe remain forever out of reach. As we continue outward, we arrive at one of the strangest consequences of cosmic scale. There are regions of the universe we may never be able to reach, see clearly, or interact with in any practical sense. Not because they are hidden behind walls or blocked by matter, but because space itself changes while light is traveling through it. Distance is not always static. The stage on which everything moves is expanding. For much of human history, it seemed natural to imagine the universe as a fixed backdrop filled with stars. But modern astronomy revealed something more dynamic. Galaxies, on average, are moving away from one another as space stretches between them. This expansion was first recognized through observations associated with Edwin Hubble, who found that more distant galaxies tend to show greater recession. It was not that galaxies were simply flying through empty space like sparks from an explosion. Rather, the space between large structures was increasing. A useful way to imagine this is dots drawn on the surface of an inflating balloon. As the balloon expands, each dot sees the others move farther away, even if the dots themselves are not crawling across the rubber. No single dot sits at the center of the surface. Expansion happens everywhere at once. The universe is more complex than a balloon, of course, but the analogy captures an important idea. Motion can come from the stretching of space itself. This leads to a surprising consequence. Very distant galaxies can recede from us effectively faster than light due to expansion, not because they are locally breaking the speed limit of physics, but because the space between us and them is growing. Light emitted from such regions may still travel normally through local space, yet the total gap can continue increasing faster than the light closes it. In practical terms, some destinations become unreachable, not through lack of speed, but because the road itself lengthens as you travel. Astronomers describe related boundaries with ideas such as the cosmic horizon and the cosmological event horizon. These horizons mark limits to what can ever influence us. There are galaxies whose present-day light may never arrive here, no matter how long future civilizations wait. We can receive ancient light they emitted long ago, but newer messages may remain forever beyond reach. There is something almost poetic in this. Parts of reality may exist permanently outside our future conversation, not hidden by secrecy, but by geometry and time. The universe contains separation written into its expansion. This does not make the cosmos smaller. In a sense, it makes it larger and stranger. It means visibility and existence are not the same thing. What we can observe is shaped not only by instruments and patience, but by fundamental limits built into cosmic history. There may be immense regions beyond our horizon filled with galaxies, stars, and worlds whose light will never meet us. And yet, even within these limits, what remains observable is astonishingly rich. Billions of galaxies, ancient radiation, evolving stars, black holes, planets, chemistry, and structure across unimaginable scales. We are not deprived of wonder simply because some doors remain closed. If anything, mystery survives. It also offers perspective on human knowledge. We often assume progress means total access, that eventually everything will be known. But the universe may not be arranged that way. Some truths may remain forever indirect, inferred rather than seen. Boundaries are not always failures of intelligence. Sometimes they are features of reality itself. So when we speak of a light year, we are not merely measuring distance. We are brushing against the limits of contact, causation, and visibility. Space is not just large, it is structured in ways that determine what relationships are possible. In the next part of our journey, we will return from these distant horizons to something closer and more intimate. How knowing all of this can quietly transform the way we experience our own small place within the vastness. After exploring horizons that may never be crossed, it can feel natural to return to something nearer and more human. Because the value of understanding cosmic distance is not only found in astronomy textbooks or telescope images, it is also found in the subtle way perspective changes once those distances become real to you. A light year, a galaxy, a horizon beyond contact. These ideas can seem remote at first, yet they often echo back into everyday life in unexpected ways. When you deeply absorb that the nearest star beyond our sun is years away even at light speed, that our galaxy is 100,000 light-years wide, and that billions of galaxies exist beyond it, the ordinary scale of daily concerns begins to shift. Problems do not disappear, responsibilities do not vanish, and pain does not become imaginary. But they are no longer the entire frame. They become part of a larger picture rather than the whole picture itself. This is one reason many people find the night sky comforting rather than frightening. Vastness can be intimidating when described only through numbers, but emotionally it often creates spaciousness. The mind, so used to circling around deadlines, worries, regrets, and unfinished thoughts, suddenly encounters something too large to control. And strangely, that can feel like relief. The universe asks nothing from us in that moment except attention. Stars do not demand productivity. Galaxies do not judge mistakes. Light arriving from ancient distances carries no criticism. It simply arrives. Looking upward can become a temporary release from the narrow scale of self-concern, not because our lives are unimportant, but because they are allowed to rest within something larger. There is also humility in cosmic perspective, and humility is often gentler than people assume. To realize that Earth is a small world orbiting one ordinary star in the Milky Way galaxy does not reduce human meaning. It reframes it. Importance does not have to come from size. A poem is small, a memory is small, a kindness is small, yet each can matter deeply. Likewise, humanity may occupy a tiny physical corner of the cosmos while still holding immense significance within the sphere of conscious experience. We are small in scale, but scale is not the same thing as value. At the same time, the rarity of our situation becomes more visible. In a universe filled mostly with vacuum, darkness, radiation, and distance, the existence of oceans, forests, weather, music, laughter, language, and love appears less ordinary than it once did. Familiar things regain their strangeness. Breathable air becomes remarkable. Warm sunlight becomes remarkable. The fact that atoms forged inside ancient stars now form living beings capable of reflection becomes remarkable. Cosmic distance can make home feel more precious, not less. There is another quiet lesson hidden here as well. Much of the universe cannot be rushed. Light itself needs time. Galaxies evolve over eons. Stars are born, burn, and fade across spans longer than civilizations. Against that background, the human habit of demanding immediate resolution can soften. Not every answer arrives quickly. Not every chapter closes on schedule. Some truths require patience. In this sense, astronomy does not only teach scale, it teaches tempo. Perhaps that is why people across cultures and centuries have continued to look upward. Long before equations, satellites, or observatories, the sky already offered perspective. It reminded farmers, sailors, philosophers, and children that they belonged to something wider than their immediate surroundings. Modern science has deepened that experience, but it did not invent it. It simply gave names and measurements to a feeling humans had sensed for a very long time. So when we speak about light years, we are speaking about more than distance between stars. We are speaking about distance that can widen thought, soften ego, renew gratitude, and place temporary struggles into gentler proportion. The universe does not solve our lives for us, but it can change the angle from which we view them. And in the next part of our journey, we will return to the light year itself one final time, exploring why this single unit of measurement captures so much of what makes space feel both incomprehensible and beautiful. After traveling through stars, galaxies, horizons, and perspective itself, we can return to the light year with fresh eyes. At the beginning of this journey, it may have sounded like a technical phrase, something scientific, useful perhaps, but emotionally distant. Now it carries more weight. Because a light year is not merely a number astronomers use for convenience, it is a doorway into understanding why space feels so unlike anything in ordinary life. Few measurements contain so much meaning in so few words. A kilometer describes the world we move through. It belongs to roads, coastlines, cities, and maps. Minutes and hours describe the rhythm of daily life. They belong to meetings, sunsets, meals, and memory. But a light year combines two different human intuitions, distance and time, into one concept. That fusion matters. When we hear that something is 10 light years away, we are not just hearing how far it is. We are hearing that the light reaching us tonight began its journey 10 years ago. The unit transforms empty space into elapsed experience. It turns separation into travel time, and travel time into story. That is why the term feels so powerful. It does not merely state scale, it implies process. A mountain 30 kilometers away is simply there. A star 30 light years away is sending a message that began decades earlier. Every beam of starlight becomes evidence of persistence. It crossed darkness continuously, second after second, year after year, until finally arriving here. When you look at the night sky, you are not receiving static objects. You are receiving successful journeys. This also explains why the light year sits at the center of cosmic imagination. It reveals that the universe is not only large, but delayed. We never encounter distant reality instantly. We meet it through the travel time of light. Nearby stars show us recent chapters. Remote galaxies reveal ancient ones. The farther outward we look, the deeper backward we see. A single unit of measurement quietly contains astronomy, history, and physics all at once. There is elegance in how natural it feels once understood. To say the Milky Way galaxy is about 100,000 light-years wide immediately tells us more than trillions upon trillions of kilometers ever could. To say the Andromeda galaxy is about 2.5 million light-years away instantly evokes age, separation, and scale. Good measurements do more than quantify, they clarify. The light year does exactly that, and yet it also preserves mystery. Even after understanding the definition perfectly, the mind still struggles to feel 9.46 trillion kilometers. We can calculate it, compare it, teach it, and use it, but fully imagining it remains difficult. This is part of its beauty. The light year stands at the boundary between what humans can know precisely and what we can only partially experience inwardly. It is a bridge between certainty and wonder. Perhaps that is why space continues to captivate people who have never studied astronomy formally. You do not need advanced mathematics to sense what a light year implies. You only need to understand that light is incredibly fast, that space is incredibly vast, and that even the fastest thing known needs years to cross certain gaps. Once that realization lands, something changes. The universe feels less like a backdrop and more like a reality of staggering depth. So the light year endures because it does two jobs at once. It serves science with precision, and it serves the human imagination with scale. It lets astronomers map galaxies while allowing ordinary people to feel awe. Few ideas travel so smoothly between equations and emotion. And in the next part of our journey, we will explore one final question that naturally emerges from everything we have learned. If the universe is this vast and distance this extreme, what does it mean for the possibility of other life somewhere out there among the stars? Once the scale of the universe becomes real, another question almost always follows. If there are so many stars, so many planets, and such immense stretches of time, could life exist elsewhere? It is one of the oldest questions people ask when looking upward, and the concept of a light year gives that question new depth. Because the moment we understand how many stars exist within even a small region of the cosmos, the possibility no longer feels like pure fantasy. It becomes something scientific enough to consider seriously, yet uncertain enough to remain profound. Our Milky Way galaxy alone contains hundreds of billions of stars. Many of those stars are now known to host planets. Exoplanet discoveries over recent decades transformed astronomy by showing that planetary systems are common rather than rare curiosities. Some worlds orbit close to their stars, some far away. Some may be rocky like Earth, others gaseous, frozen, ocean-covered, or unlike anything in our solar system. What once existed mainly in speculation now exists in catalogues, measurements, and observed data. Even if only a tiny fraction of those planets possess suitable conditions for life, the raw numbers become difficult to ignore. If only 1 in a million stars hosted a living world, that could still imply vast numbers of inhabited planets across the galaxy alone. And the Milky Way is only one galaxy among billions in the observable universe. Scale changes the emotional tone of the question. We are no longer asking whether life must be common. We are asking whether nature repeated itself elsewhere across incomprehensible opportunity. Yet distance complicates everything. If a civilization existed 1,000 light years away, any signal we received today would have been sent 1,000 years ago. A reply would take another 1,000 years to arrive. Conversation, in the human sense, becomes nearly impossible across such gaps. Even if life is widespread, the universe may remain quiet simply because space is so large and light so finite. Civilizations could rise and vanish without ever overlapping in time or range. This tension is captured in the Fermi paradox. If the cosmos offers so many chances for life, why have we found no clear sign of advanced civilizations? There are many possible answers. Intelligent life may be rare. Technological societies may not last long. Communication methods may differ from what we expect. Or perhaps the distances involved are enough to keep islands of life permanently isolated from one another. There is also a humbling possibility. Life may be common in simple forms, while intelligence is uncommon. Microbial ecosystems might exist on countless worlds, while conscious technological civilizations remain sparse. On Earth, life appeared relatively early, yet complex multicellular life and technological intelligence took far longer. Evolution may often produce oceans of microbes, but only rarely telescopes. Still, uncertainty does not diminish wonder. In many ways, it enhances it. We live during the first era in history when humans can begin to test these questions scientifically. Telescopes analyze atmospheres of distant planets, space missions, search for biosignatures. Instruments study moons such as Europa and Enceladus for environments where life might exist closer to home. The search has moved from mythology into evidence-based exploration. And yet the light year keeps us grounded. It reminds us that even if life is abundant, the stars are still separated by genuine distance. Other worlds may exist, perhaps many of them, while remaining unimaginably far away. Possibility does not erase scale. Perhaps that is the deeper lesson. The universe may be full of life, or we may be extraordinarily rare. At present we do not know, but either answer carries weight. If life is common, we belong to a living cosmos richer than we imagined. If life is rare, then the existence of life here becomes even more precious. In the next part of our journey, we will turn back toward Earth and ask what these enormous distances reveal about our own planet, the tiny world from which all of these questions are being asked. After considering the possibility of life across the stars, it becomes natural to look back at the one world we know with certainty holds it. Because every discussion about galaxies, light years, and distant planets begins from a single place: Earth. All measurements of cosmic distance, every telescope image, every equation, every question about the universe has emerged from this small planet orbiting one ordinary star. The farther outward we travel in thought, the more striking our point of origin becomes. From nearby space, Earth already appears unusual. Earth holds liquid surface water, a protective atmosphere, active geology, a stable range of temperatures, and chemistry rich enough to sustain vast ecosystems. Clouds move across oceans, forests exchange gases with the air, seasons cycle, and millions of species interact in layered complexity. To those living within it, these things can feel normal because they are familiar, but familiarity often hides rarity. In a universe dominated by vacuum, radiation, darkness, and extremes of heat or cold, a living world may be something extraordinary. The light year helps reveal this contrast. When we hear that nearby stars are separated by years of travel even for light itself, Earth begins to feel less like a default setting and more like a sheltered island. Across interstellar space lie immense regions where no human could breathe, drink, or survive unprotected for even moments. Between stars there are no forests, no rivers, no weathered stone paths, no bird song at dawn, no atmosphere carrying scent after rain. There is mostly silence, sparse particles, and distance. Against that background, even the most ordinary earthly scene gains new depth. A street after sunset, wind through trees, warm bread in a kitchen, waves meeting ashore, someone laughing in another room. These moments may seem small when viewed from inside routine, yet cosmic perspective can make them luminous again. In a galaxy of hundreds of billions of stars, on a planet small enough to vanish from afar, consciousness experiences taste, memory, music, grief, humor, and love. That combination is not something we should assume is common simply because it surrounds us daily. There is also something remarkable about Earth's position in time. We exist during an era when the planet is habitable, the sun remains stable, and intelligent observers have emerged capable of understanding their environment. For billions of years, Earth had no cities, no telescopes, no spoken theories of stars. For billions more, none may remain. We occupy a narrow window in which life can ask where it is. That alone gives the present moment a certain quiet significance. None of this means Earth is the center of the universe. Science moved beyond that idea long ago. Our planet is not physically central, nor is our sun special among stars. But centrality and preciousness are different concepts. A family photograph is not the center of the world, yet it can still be treasured. Likewise, Earth may be cosmically ordinary in location, while being extraordinary in meaning to every life form that has ever known home. The light year also teaches responsibility. If habitable worlds are rare, then protecting one becomes urgent. If they are common, Earth still remains the only living world we can currently reach and care for directly. Either way, distance removes the illusion of easy replacement. There is no nearby second home waiting casually around the corner. Even the closest stars are separated by daunting spans of space and time. So as our perspective expands, appreciation can deepen. Earth is small, yes. Vulnerable, yes, but also astonishingly rich. Mountains shaped by ancient forces, oceans carrying memory of deep time, ecosystems woven through fragile balance, minds capable of kindness and curiosity. This tiny world has produced art, science, stories, and the ability to measure light years. In the next part of our journey, we will explore a final paradox of cosmic scale, how something so vast can make us feel smaller, yet somehow more connected at the same time. One of the strangest gifts of cosmic perspective is that it can produce two opposite feelings at once. On one hand, the universe makes us feel small. The distances are immense, the timelines stretch beyond comprehension, and our planet is only a tiny world orbiting one star among countless others. But on the other hand, that same vastness can create a deep sense of connection. Rather than making us feel irrelevant, it can remind us that we belong to something far larger than ourselves. The feeling of smallness usually arrives first. When you learn that the Milky Way galaxy may contain hundreds of billions of stars, and that billions of galaxies exist beyond it, the ego naturally loses scale. Personal dramas, social status, and daily frustrations no longer appear as the center of reality. The universe does not rearrange itself around our preferences. Seasons pass, stars burn, galaxies turn, and cosmic history continues whether we are anxious or calm. This realization can sting at first, especially if we are used to measuring everything by personal importance. Yet once that first reaction softens, another feeling often emerges. If we are made from the same physics as everything else, then we are not outside the universe looking in. We are expressions of it. The atoms in your body were forged through ancient cosmic processes. Hydrogen born near the beginning of the universe, heavier elements created in stars, matter recycled through explosions and clouds of gas eventually became planets, oceans, biology, and thought. Stellar nucleosynthesis is not just an abstract scientific idea, it is part of your own origin story. This changes the emotional meaning of smallness. A drop of water is small compared with an ocean, yet it still belongs to the ocean. In the same way, a human life is brief and local compared with cosmic scales, yet still belongs fully to the larger whole. We are not separate from the universe. We are one way the universe became aware enough to ask questions about itself. There is also connection in shared circumstance. Every person who has ever lived has done so under the same sky, on the same earth, carried through space together. Borders, identities, conflicts, and ambitions can feel absolute from ground level, but from a wider perspective they become local arrangements on one small planet. The atmosphere that sustains one nation sustains all nations. The sunlight that warms one city warms every continent. Cosmic distance can reveal unity not through sentiment, but through fact. Even time connects us. The light from distant stars that reaches your eyes tonight may also have reached ancient observers long ago, though in different moments and from a moving earth. People separated by centuries have looked upward and wondered many of the same things. Different languages, different beliefs, different eras, yet a common instinct to seek meaning in the sky. That continuity matters. Curiosity itself becomes a thread linking generations. There is comfort here. You do not need to be large to belong. You do not need to be permanent to matter. Forests are temporary. Music is temporary. Sunsets are temporary. Their value does not depend on lasting forever. Likewise, a human life may be brief against billions of years, yet still meaningful within the scale where love, memory, courage, and consciousness exist. So the paradox resolves itself gently. The universe makes us smaller only in one sense, physical proportion. But it can make us larger in another sense, identity, perspective, and connection. We stop being isolated individuals at the center of everything and become participants in a much grander reality. In the next part of our journey, we will bring everything together and return to the simple phrase that began it all, light year, and see why this single idea continues to capture the imagination of anyone who truly pauses to think about it. After everything we have explored, stars, galaxies, horizons, time, life, earth, and belonging, We return once more to the phrase that began this journey: light year. Two ordinary words joined together, and yet they contain one of the most powerful invitations in science. At first glance, the term sounds simple, almost casual, but the moment you slow down and truly consider it, an entire universe begins to unfold. A light year is the distance light travels in 1 year through empty space. That definition remains accurate, but now it feels far less complete. We know that within it lies nearly 9.46 trillion kilometers. We know it is the span between stars, the scale of galaxies, the ruler used to describe the architecture of the cosmos. We know it transforms the night sky into a timeline, where distant objects are seen not as they are now, but as they once were. And we know it reveals something deeply human as well, the difference between what can be calculated precisely and what can only be felt slowly. Few ideas bridge so many worlds at once. The light year belongs to physics because it depends on the speed of light. It belongs to astronomy because it maps space. It belongs to history because distance means delay. It belongs to philosophy because it forces us to reconsider scale, importance, and perspective. And it belongs to imagination because, even after understanding it, the mind still struggles to contain it fully. That struggle matters. There is value in encountering realities larger than intuition. Much of modern life encourages the opposite. Everything instant, compressed, optimized, and made manageable. A light year resists that habit. It cannot be reduced into something emotionally convenient. It asks patience. It asks humility. It asks the mind to stretch beyond familiar proportions and sit with vastness long enough for wonder to return. It also reminds us that the universe is not built to human scale. Roads fit our bodies, buildings fit our needs, clocks fit our routines. But the cosmos was not arranged around our instincts. Stars are separated by years of light travel. Galaxies drift across millions of light years. The observable universe spans distances so immense that language begins to thin at the edges. And yet, from a small world orbiting an ordinary star, conscious beings learned how to measure it. There is quiet beauty in that contrast. The universe is unimaginably large, but not unreachable to thought. We may never physically cross most of what we can observe, yet understanding itself becomes a form of travel. Through mathematics, telescopes, and reflection, the human mind has already moved far beyond the limits of the body. Every time someone truly grasps what a light year means, even briefly, perspective has traveled outward. The term also carries a certain emotional honesty. It tells us that some things take time. Light needs years to cross certain gaps. Knowledge took centuries to build. Understanding often arrives gradually. The most meaningful realities are not always immediate. Some truths must travel before they can be received. So perhaps that is why the phrase endures. A light year is more than a measurement. It is a reminder that reality contains scales beyond convenience, distances beyond instinct, and beauty beyond urgency. It teaches that being small does not prevent us from understanding something vast. It teaches that wonder can survive familiarity. And it teaches that even in a universe of staggering size, a thinking mind can still meet the stars halfway. In the final part of our journey, we will slow down one last time and leave with the deepest perspective this idea offers. Not how big space is, but what it means to be here at all within something so immense. And so we arrive at the end of this journey, where the question is no longer how far a light year reaches, but what it means that we are here to ask. We began with a unit of measurement, a scientific phrase that seemed simple enough on the surface. But step by step, it opened into something much larger. It showed us stars separated by years of light travel, galaxies spread across millions of light years, and an observable universe extending across distances so vast that ordinary language can barely hold them. Yet after all of that scale, the most remarkable fact may not be the size of space at all. It may be consciousness within it. Because in a universe filled mostly with silence, darkness, radiation, and immense emptiness, there exists at least one small planet where matter learned to notice itself. On Earth, atoms formed oceans, chemistry became life, life became awareness, and awareness began to wonder. From forests, deserts, cities, coastlines, observatories, and quiet back gardens, human beings looked upward and asked what those lights were. Over time, curiosity became mathematics, mathematics became measurement, and measurement revealed the scale we explored together. The same universe that forged stars also produced minds capable of understanding light years. There is something deeply moving in that sequence. We often imagine ourselves as separate observers standing outside nature, studying it from a distance. But we are not outside it. We are one of its outcomes. The universe did not merely create galaxies and planets. It also created the possibility of reflection. Through conscious beings, it gained eyes that can see, language that can describe, and questions that can reach back toward their source. This does not make humanity the center of everything. The cosmos is far too vast for that old idea, but it may make awareness itself precious. A star can shine for billions of years without knowing it shines. A galaxy can turn in silence without knowing it turns. Here, on one small world, there are creatures who can feel rain, compose music, grieve losses, love one another, and understand that starlight left its source long before arriving tonight. That combination of sensitivity and knowledge may be rarer than size alone would suggest. The light year teaches another final lesson as well. Distance does not erase connection. The sun touches Earth across 150 million kilometers through warmth and light. Ancient stars touch our eyes across years. Distant galaxies touch our instruments across millions or billions of years. Even across emptiness, relationships exist. Gravity reaches, light reaches, influence reaches. In a quieter way, meaning reaches too. A person standing under the night sky can feel linked to realities unimaginably far away simply through understanding them. And perhaps that is enough. We do not need to own the universe, cross all of it, or solve every mystery within it. There is dignity in participation. To be here briefly, on a small planet, during a narrow window of cosmic time, and to notice what surrounds us, that is already extraordinary. We are temporary, yes, but temporary things can still hold immense value. Music ends, sunsets fade, lives are finite. Their brevity does not cancel their beauty. So the next time you hear the phrase light year, perhaps it will sound different, not just as a distance, but as a symbol of scale, patience, history, and wonder. A reminder that reality is larger than instinct, richer than routine, and more beautiful than haste often allows us to see. A reminder that the night sky is not a ceiling, but a depth. And a reminder that among all that vastness, you are one of the rare places where the universe has become aware enough to listen to itself. Thank you for spending this time with us, for slowing down, for wondering, and for traveling outward through thought alone. Wherever you are in the world tonight, we hope this journey brought a little more calm, perspective, and awe. And when you next look up into the dark, may the stars feel just a little closer, even across all those light years.